Okay, definite integrals basic, example 2. All right, in this example, we're going to do exactly the same thing, solve the exact same problem, but in a different way as we did in example 1. Remember that problem was that dh dt is 14.7 minus 9.8 t, and we want to find, and we want to do two things. What do we want to do? A, we want to compute the change in h over 0, 1.5. And part B, change in h over 0, 3.5. It's a terrible looking 0 there. Okay, much better. Okay, in example 1, we did this using areas of triangles. We can do this another way. So another way to do this is to find a formula for h. Okay, so the way we're going to do this today is we'll, find formula for h of t, right? Remember that this is another way of saying h prime. So if this is h prime, we can take the antiderivative to find h. Then 2, we'll compute each of these pieces. Okay. All right. Okay, so this is h prime, so we'll find h. H of t, 14.7t minus 9.8 t squared over 2 plus some constant. Okay, now if you're worried about, hey, we don't have an initial condition to find that constant, that's a good thing to be worried about. But guess what? It won't matter. You'll see. Okay, so 9.8 divided by 2 is 4.9. 4.9t squared plus c. Okay, so there's h of t. Okay, so for part A, right, we want to find change in h over 0, 1.5. Okay, so to do this, so the change in h is whatever h of 1.5 is minus h of 0. Okay, so change of h equals h of 1.5 minus h of 0. H of 1.5, plug a 1.5 into each of these here. H of 1.5 is 11.025 plus c. So h of 1.5, put in a 1.5 in here, right? I don't know what the constant is, right? I don't know what the constant is, so I just have that constant sitting out there. Okay, minus h of 0 is just going to be, and put a 0 in here, right? You get a 0, and a plus c. So you have the c there. And notice in this case that the c's cancel, and we get 11.025. Which is the same answer we got for A, doing it graphically. Okay. Okay, h of 3.5, and you can check, you plug in 3.5 into each of those spots there, and you get negative 8.575 plus c. Minus positive c. Okay, so again, those cancel. We see that actually gives you exactly the same answer that we had for part B using the graphical approach. Okay, so what do we see here? What do we get from all this? Okay, putting these together, right, we see that okay, this relationship is true in general.